Recursion is a technique in which a function calls itself repeatedly to solve a smaller instances of the same problem. So, to implement a recursion iteratively or recursively, a stack data structure can be used. Since a recursive function repeatedly calls itself, it makes use of the stack data structure to temporarily store the return address and also the local variables of the calling function. Every recursive solution, if you take, there are two major cases. One is the base case and another one is the recursive case. Base case means it is in which the problem is very simple enough to be solved directly without making any further calls to the same function. So, when exactly the problem would end means when it reaches the base case, because since it is calling itself repeatedly, there should be some ending point. So, there must be a base case for each problem. When it reaches the base case, it would end the problem, the recursive call would end when it reaches the base case. And a recursive case means in which first the problem at hand is divided into simpler subpart, that is the first step, and as a second part, once the problem is divided into simpler subpart, the second step is the function would call itself repeatedly but with the subpart of the problem which was obtained in the first step. So, recursively it would call, the function would call itself repeatedly which was obtained from the previous step, and third, the result is obtained by combining the solutions of subparts. Therefore, the recursion is defining large and complex problems in terms of smaller and more easily solvable problem. Generally, in recursive functions, a complex problem is defined in terms of simpler problem, and simplest problem is given explicitly, which is also called the base case. So, it would end exactly when it reaches the base case. Let us take one example. Let us consider an example using the factorial function which calculates the factorial of non-negative integer n. Let us take this example, and this is the pseudocode. If you check the pseudocode, n is the number for which you want to find the factorial. For example, I want to find factorial for 4. This is the task. This is the given pseudocode. So, I want to find the factorial for the integer value 4, and this is the base case. You have to check if n value is equals to 0 or if n value is equals to 1, it has to return 1. This is the base case. And this is the recursive case. It has to work on this only, this formula only, which I have specified here. N factorial equals to n into n minus 1 factorial. This has to be repeatedly called until we reach the base case, until n becomes 1, and this is the formula. So, generally if you take we want to find the factorial for the number for the integer value 4. If you want to find the factorial value for 4, you have to check whether n value is equals to 0 or 1. No, n value is not equals to 0 and it is not equals to 1 as well. If it is equals to 0 or 1, it is a base case, it has to return the value 1. Otherwise, we have to apply the formula n into factorial of n minus 1, right. So, if you want to know what the factorial of 4, you need to know according to the formula n into n minus 1 factorial, right. So, n is 4 and n minus 1 is a recursive call. So, factorial of 3 you need to know, which means if you want to know what is 4 factorial value, you need to know what is 3 factorial, right. So, here you need to use the stack function, because we are calling the function recursively, like each and every function calls a new function in each iteration. So, create a stack. I want to know 4 factorial. If you want to know 4 factorial, you need to know what is 3 factorial, then only the answer would be reached, right. Like if you want to know 4 factorial, 4 into n minus 1 factorial is required. So, 3 factorial is required. So, when this would get complete, calling 4 factorial would get complete. When you know the answer for 3 factorial, you will get the answer for 4 factorial, right. So, since you want to know, again this is a recursive call, you need to know what is 3 factorial. So, this 3 factorial function should get complete first. The execution of this should get complete to know what is 4 factorial. Push 4 factorial into the stack. Then again, if you want to know what is 3 factorial, again the formula is factorial of n is, the formula is n into n minus 1 factorial. Here n is 3 into 2 factorial you need to know. When the execution of 3 factorial would get complete, when the execution of 2 factorial is getting complete, 3 also would get complete. So, you need to work on 2 factorial now, right. Until you complete the execution of 2 factorial, you need to push this 3 factorial inside the stack. Now, if you want to know what is 2 factorial, you need to know what is 1 factorial. Formula is n into n minus 1, n is 2, n minus 1 is 1. You need to know what is 1 factorial, which means 1 factorial, right? So if you want to know what is 2 factorial, you need to know what is 1 factorial. So now you push factorial of 2 inside and you work on 1 factorial. Now you work on finding out the value for 1 factorial. If you check the n value is 1. If n value is 1, this is the base case, right? If n is equal to 0 or 1, the value would become 1. So you know what is 1 factorial now. 1 factorial value is 1. So 2 into 1, factorial of 2 is 2. So since factorial of 1 execution is completed, you know what is 2 factorial is. You pop out 2. And you know what is 2 factorial, which is 2. 3 into 2, 6. So factorial of 2 is over. You just pop out 3. Since execution of factorial 2 is completed, you just pop out factorial of 3 also. Now 4 into 6, which is 24. Since execution of 3 factorial is completed, you can pop out factorial 4 also. So this is how the stack data structure would work when it comes to the recursion. So if you want to call something recursively, like each and every, suppose you are calling function A, but function A calls function B, then again function B calls function C. If so, like until, for example, A calls B, B calls C. When B would get, the execution of B would get completed, when execution of C is over, then B would get completed. Until the execution of C is getting completed, you're supposed to push B inside the stack. If you want to if you want B to get completed, because only when B is completed, A would get completed, right? So until like B is getting completed, A also should be pushed onto the stack. So when you recursively, when you call the new functions in each iteration, so you only with the help of the stack data structure will be able to